As discussed in our previous lesson, we were talking about what sine graph looks like, what the cos graph looks like, and I said to you that just like when we looked at quadratics, there are different variables that affect how the graph is going to look. So if we're looking at what we've got here, which is our y equals sine, right? Y equals sine x. So sine x would just be what we have as our normal graph, where x is, of course, my 1 up or whatever it might be. So if there's a multiple here, this multiple is going to affect my amplitude. So my amplitude is this, how far my curve goes up, how far my curve goes down from the reference line. The reference line can be moved with c. So this c value could mean that the reference line is up further, so it comes up here, or it's down below the x-axis, right? So the reference line is not always going to be the x-axis, but it is if there's not this existing. This will just mean that the reference line is at the x-axis. This variable is a little bit different from what you would expect. So this multiple here in front of the x is going to affect the stretch, so how far my period is. Normally my period is 360, but if this b variable was half, so I've got half x, then actually my period is no longer 360, it becomes 720 to do one cycle. Or if it's 2, then it goes the other way, so it would be from 360 to 180 to go through one cycle. Of course, we're talking about the fact that x here is theta. It won't always be theta depending on what the question is asking you about. Okay, so what about if I have to graph this? We can look at this one and see that there is 3 added variables in there. So this one here is 2, right? That's going to change the amplitude and it's going to flip the graph. So rather than my first bit but it being up in this side, it's going to be down here when I make my first point. You can also see that I have reduced the x. So the x doesn't go all the way up to 360 anymore, and that's because of this variable. This variable is telling me that it's only going to have a period of 180 degrees, right? This one, of course, flips and makes the amplitude is now 2. From the reference line though, right? So I have to work out where the reference line is. This is my reference line. So before I can do anything, I'm going to have to plot that in. I'm going to do that first. I've done my reference line first so that then I can plot my points, the points that we know will exist according to what we look from the unit circle, right? So normally at 90, I would have a amplitude of 1 on the normal graph, but it's going to be 2, and of course my period is reduced, so now that's going to happen at 45 instead of 90, so they all just move 1 that way. So this now becomes down here, and I'm going to put it at 2 from the reference line. So from the reference line, I can see here that 0 is 1, and then at -1 is going to be where I have my first point. So I'm going to start actually up here. So this will start with my curve. And then at 90, it's no longer going to be down at 0, it's going to be at 90, it's no longer going to be at 1, it's going to be at what we would call 0, but 0 is actually going to be up here. Okay, and then same as what we would always do, so at 135, it's going to be down here, 2, right, and, sorry, we're doing one cycle, confusion there, this one, have to remove this one, oh, I can't remove that one, it's alright, so actually at 135, it's going to be up here, at 2 from the reference line, so that's up at 3, and then back down to 80 would be on the reference line. So our 3 points which we know would have been on the reference line are still there. That's this one, and this one, but they've been pushed this way, right? Because, of course, my period isn't as big. And the ones that used to be, so this one which used to be here, actually up here, is now flipped and a little bit closer. And same with my 135, it's now flipped, but it's up here. And then I can draw my graph. I can just go back and make sure that I haven't missed anything. Yep, I've reduced my period. I can see it in the scale. It's all going to happen down here in the scale rather than actually with the graph. The graph, we would only notice if we were comparing this graph to then a normal sine graph, which we would do using our CAS calculators. We can see that the points are all in the right spots. Make sure that they've just been flipped from where they would have been. Our amplitude is at 2 from our reference, so it's all good. And this curve, of course, will keep moving on and on depending on how big we're making it, and depending on what it says. It might say that it wants to show an extended period, in which case it'll show 2 cycles. But if we are given this equation, it's just asking us to show one and make sure we put in all the bits that are necessary. So that's our points, our period, everything that pertains to where the points are going to go. Make sure we've got enough on our y-axis, and then of course just sketching it nice and evenly. As you can see, mine's not perfect, but yours will be much better because you'll have graph paper. It's important for us to practice all the concepts we've looked at now with the unit circle, bringing them all together before we establish how we use algebra with our solving. So you need to go back through Pearson exercise 6.2 and have a look at the questions through there. You can have a look. You can see some questions will be really easy because we've already done some things on those, so you can just skip through. Some questions are more difficult and definitely consolidate the things we've just been looking at. So questions like question 9, you can look at how you can find things on the CAS calculator and review the period, amplitude and so forth in looking at how they affect the graph.